Question 9.4, we're going to do some more work that's really kind of anticipating stuff that we're going to need when we start solving quadratic equations. So it's more work simplifying radicals. And I want to start out with a really basic one where we're going to multiply two radical expressions. Now, if you look at this, everything is being multiplied. 8 times this, times this, times this, etc. And the thing about multiplication is that you can switch the order. So for my convenience, I'm going to rewrite that as 8 times 3 times square root of 7 times square root of 5. And now, well, 8 times 3, that's 24. And square root of 7 times square root of 5, I can bring that together as square root of 7 times 5, or basically square root of 35. So the bottom line when you're multiplying these kinds of expressions is what's outside multiplies what's outside, or the outside, and then inside times inside. That's kind of a crude way to put it, but that's really what's going on here. So that you don't necessarily have to go through this middle step here. It'd be nice if you could just, in your head, multiply the outside stuff. So the 8 and the 3, that's your outside times the outside. And then likewise, inside times the inside. So that's what's going to go on. We're going to have to do that in more general situations. So for example, like this, 7 times the square root of 5 times 4 square roots of 3 plus the square root of 6. Now when we multiply something like this together, really what's implied is that you have to distribute this. This term here is going to multiply itself times this first term plus the product of that second term. So let's look at this together. And I don't know, if you'd like, on this first example, I could write it out in great detail like this, or we can just kind of start jumping straight to the answer. Any preference? Want to see a little more detail on this first one? And then, yeah.
I would.
Okay, all right, yeah, thanks. So we're going to take this term, so 7 times the square root of 5, and multiply it by this term, which is going to be your 4 square roots of 3. And then the 7 times square root of 5, maybe I should write that in orange here, is going to multiply the square root of 6. So 7 square root of 5, and then square root of 6. Now what I said just a minute ago still applies here. The outside stuff is going to multiply together. So 7 times 4 is 28. And the inside stuff is going to multiply together. 5 times 3 gives me 15, but that 15 is going to be under the square root here. So we'll keep that in yellow, and the product here is in pink. We have to do the same thing for this second term. So that second term is going to be separated by an addition sign. What does the 7 multiply? Yes, thank you. You have to imagine there's a 1 out in front of this. So 7 times a 1, that's just going to be 7. And finish it up, Rachel. What's going to be under the radical?
30.
30. Perfect. 30. And that's it. So that 7 just multiplies an imaginary 1 or an understood 1. And then 5 times 6 is square root of 30. That's it. All done with that one. Let's try another one. Kind of similar. Before I do, are we okay with this one? Thumbs up on that one? Yeah. All right. So we'll do this as example B. This time I'll do 3 square roots of 7 times 7 minus the square root of 7. So too many 7s for my liking in this problem, but this one I think it was inspired by a WebAssign problem, so we'll do it. This whole thing is one term, and that's going to have to distribute itself to both of these terms. So this, and then times this. Now I will do it all out, kind of like I did the previous example one more time. So it's going to be, bless you, 3 square roots of 7 times 7, then the minus, and then 3 square roots of 7 again, this time times the square root of 7. But you're still going to stick with those outside and inside products. So this is the greatest SI I ever had, supplemental instructors. We don't have one for this course, but I wish we did. That one. Yeah. So let's take a look at this one. What's going to multiply together? Is the 3 going to multiply the 7 here or the 7 here?
Similar.
Yeah, the second one. So the 3 is outside, it stays outside, so 3 times 3. What am I going to get when I multiply this together? 21 square root of 7. Perfect. Minus. And I got to think a little bit on this one. This time, it's going to be minus 3 times the square root of 49, right? Because the 7s are going to multiply each other. So, nice. So 21 square root of 7 minus, I hope you don't leave it like this.
7.
Yeah, so minus 3 times 7, and 3 times 7 is 21. So 21 square roots of 7 minus 21. It's tempting, but can I subtract this and just write square root of 7?
No.
No. This would have to have a square root of 7 on it in order for us to combine things. Remember from the last section, we can combine those kinds of things if you have like terms. So for instance, here we said 4 square roots of 3 minus 5 square roots of 3. 4 minus 5 was our minus 1. You could combine those, but you couldn't combine it with something that's not a like term. And because this doesn't have a square root, it's not a like term. All right. Let's see. Let's keep going. Example C. 5 square roots of 7 plus 3 and 2 square roots of 7 minus 3. So it might not be a bad idea to write this out like we did up above. And there's one more thing that's a little bit different about this one. You've got a binomial times a binomial. What's the word that comes together when you multiply binomials together? FOIL. So you want to go through first, outside, inside, last. All right, if you're watching this later, give yourself a chance to do this one and resume after the pause button disappears. Square root of 49 is 7. Square root of 7, so it should be 10 times 7. Minus 15 plus 6. Okay, so in walking around, I saw a lot of people liked actually writing it all out, so I'll write it all out in detail. So let's see. That's going to be 5 square roots of 7 times 2 square roots of 7. And then a plus times a minus is going to be a negative. So let me just put that negative out there. Negative 5 square roots of 7 times 3. The middle terms, a positive times a positive, so a plus 3 times 2 square roots of 7. And then the last terms, I'm not going to do anything special there. It's just a minus 9, those last terms. The outside terms multiply each other. So 5 and 5 gives me a 10. Square root of 49. Minus 15. Square roots of 7. Plus 6. Square roots of 7. Minus 9. So a very common mistake in simplifying this stuff is to write that as 10 times the square root of 7. Square root of 49 is 7, so it's just 10 times 7. We've got like terms here and here. What do I get when I combine minus 15 square roots of 7 and 6 square roots of 7? Negative 9 square roots of 7, minus 9. 10 times 7 is 70. What's 70 minus 9? 61. So should end up with 61 minus 9 square roots of 7, and that's it. Now you can make these problems a little bit shorter for yourself if you just kind of do some of the stuff in your head. So that is, you do the 5 times 7, 7 times 7, do that step in your head. And that's where we're going to head on the next couple examples, is doing some of that stuff in our head. Comments on example C first. We okay with that one? Let me give you an example of a problem that is pretty much guaranteed. You can put a little star by this in your notes, or if you're taking those 2-column notes like our guest speaker suggested the other day, and again, you can put some special annotation there, but expect something like this. Square root of 5x minus square root of 3 squared. Now I like that one because I want to get you in the habit of recognizing that I can't cheat on this. It's not equal to 5x minus 3. You can't simplify it like that. In general, a minus b squared does not equal a minus b, or a squared minus b squared. It just doesn't. You can't square it out like that. So what do I have to do for something like this? We can't really just distribute the 2. That's what I was kind of hinting at.
You write the trellis.
Yeah. write this thing twice. So when you're squaring something, you're multiplying it by itself. So I want to start by writing square root of 5x minus square root of 3 twice. And then work from it. So from here, we can FOIL this out. Let's see about getting those terms. So, Emmy, what would 5x times 5x be?
25x squared.
Nice, 25x squared. And then I've got a positive times a negative, so let me put a negative here. And Sarah, 5x times 3.
15. Square root of 15.
Yep, square root of 15x. Notice the middle term, I get the same thing, right? I got a minus times a plus, so that's going to be a minus. And if you notice real carefully, I'm leaving myself a little extra room here, 15x. The last term is a minus times a minus, so that's going to be a plus square root of 9. There's an awful lot of interesting math that happens on this. Not all of it's right. So let me try and help you reach the right conclusion. The right conclusion is not a minus square root of 30 in here. Nick, any suggestion what I would get when I combine minus 1 square root of 15x and minus 1 square root of 15x again?
Minus 2 square root of 15x.
Nice. So just combine the coefficients here. I've got minus 1 and minus 1 gives me minus 2 square root of 15x. Perfect. That's the biggest mistake I see on all these. The other mistake is that sometimes people just change the signs and then get it wrong that way. Hannah, help me out with these outside terms. This one's a 3, but how about this one? What would that simplify to?
5.
5 and then x, right?
Thank you.
You're welcome. And that's it. That's as far as we can go. None of these are like terms. None of them simplify any farther. So that's it. In this example, these two terms had the same sign. And I didn't get any nice cancellation there, so that I got some further simplification of this expression. But what if these had different terms? What if they had different signs? So for example, let's do example D here. What if I had square root of 7m plus square root of 3n square root of 7m minus square root of 3n? The important thing you should see is that these have different signs. In fact, that's the only difference between one of these and the next, right? Is that they have a change of signs. Let me throw out a fancy word. These are called conjugates. That's when you have a plus b times a minus b. So this is your first binomial. Its conjugate is the second binomial. Basically just opposite in sign. All right, so again, another product of binomials. We're going to go through first, outside, inside, last, and see what happens here. Jameson, maybe you can help me out. These are both inside, so inside times inside. It's going to be
Square root of 49 m squared.
perfect. And then a minus, who's saying here? How about these terms? What's that going to give me?
21 mn.
21 mn. The middle term is going to be a plus. Plus what? John?
21 mn.
21 mn. And awesome. The last term, Sterling, be the last one. So 3 times 3, 9. Yep, thank you. And the second power. There's something delightfully different about this one as opposed to the last one. Does anyone see it? Yeah, you've got a -1 here and a +1. These cancel out. That's really cool. Those cancel out all together. Ryan G. What do these simplify down to?
7m and -3n.
Perfect. That's kind of a nice result. Given the mess that we started out with, to end up with something so nice like that is really cool. The important thing I want to get across is that's kind of stuff's going to happen when you multiply conjugates. You may remember factoring. This is really the factorization of the difference of squares. That's all that is. So those middle terms, when you multiply them together, are going to disappear. They're going to add to 0. So let's keep this in mind. We're going to need this result a little bit later when we do some division. But that when we multiply things like this, multiply conjugates, you get some nice simplification. The big thing is you've got to change the sign from one to the next. Up here, when we didn't have a change of sign, I didn't get some nice simplification in the middle. But if I did have a change of sign from one to the next, the middle term dropped out. All right. Let's see. We're going to work with rationalizing the denominator. So, example E. So the instructions are going to be rationalize the denominator. That's going to mean essentially no fractions underneath the square root and no radicals in the denominator. So no fractions under the radical and no radicals in the denominator. That's effectively what is meant here. Or a couple of things that are excluded from your answer. So if I were to give you something like the square root of 2 over 7, then you could look at that and say, all right, well, no fractions underneath the radical. So very cleverly you say, all right, well, I'll write that as square root of 2 over square root of 7. Problem solved. But then I point to this one, I'm like, well, we can't have a square root in the denominator. All right, now you've got to think a little bit. This is an expression. It's not an equation. I can't multiply both sides by something to get rid of something. My only trick in simplifying expressions is to multiply by 1. But the question is, well, what form of 1 should I choose? And here, I've got a suggestion. What if I multiply by the square root of 7 over the square root of 7? Essentially, that's the number 1, right? Something over itself. But instead of canceling these, I'm going to multiply things out. In the numerator, I get the square root of 14. What do I get in the denominator? Square root of 49. And square root of 49 simplifies, yep, thank you. Simplifies to 7. How could I check that if I looked at that? I'm like, I hate getting these problems wrong. How could I check it if I didn't feel comfortable? Calculator, absolutely. So let's clear this stuff out and check it on both ends. Square root of 2 divided by 7. And there. And then compare that to square root of 14. And here's the part where you gotta be a little bit careful. You gotta hit the right arrow to get out from under the square root and then divide by 7. Looks pretty identical. So you can feel comfortable with your answer in both cases. Let's try another one. And I'm gonna do this next one in 2 different ways. And it's up to you what way you prefer. Both are gonna get us the same answer. Square root of 3/8. We'll start out by writing as square root of 3 over square root of 8. And maybe based on what we did up above, you've got an idea of what's going to come next. What could I do next? If I want to get rid of that square root of 8 in the denominator.
Multiply by 8, or square root of 8.
Perfect. We're going to multiply by the square root of 8 over the square root of 8, which is effectively multiplying by 1. In the denominator, you get the square root of 64. In the numerator, you get the square root of 24. In the denominator, that's just 8. But we're not done with the numerator. What else should I do with the numerator? What else could I do with the numerator? Think about what we did in the last section. Sterling?
I broke it out into 6 digits.
All right, good. So it's square root of 4 times square root of 6, which is 2 times 6, or 2 times the square root of 6, like you mentioned. Because everything is being multiplied here, multiplied in the numerator and this in the denominator, I can cancel the 2 into the 8. Square root of 6 over 4. That's my final answer. Let's try it a different way. And it's up to you. I will ask you out of curiosity, but it's completely up to you what you like, what's easiest for you. We'll start out with the same thing. Square root of 3 over 8. I'll write this as square root of 3 over square root of 8. But instead of multiplying by root 8 over root 8, let's take a critical look at the denominator. Is there anything I can do with the square root of 8?
You can square root it.
Square root of what and square root of what?
2 and 4.
2 and 4. So that gives me the square root of 3 over 2 square roots of 2. All right, now I've simplified the denominator all I can. So now, what can I do to get rid of that square root of 2 in the denominator?
Square root of 2 everything.
Square root of 2 in the numerator and square root of 2 in the denominator. That's going to be square root of 6 over 2 square roots of 4. How does the denominator simplify?
2 times 2.
2 times 2, which is 4. So, same thing either way. Whatever works for you is fine. But you don't have to feel like you have to do one or the other. Just out of curiosity, which one's a winner for you? Which one do you like better?
I like the bottom one.
Bottom one more? I mean, I kind of prefer the bottom one more. See, Sterling thinks the same way. See, great minds think alike, so cool. Sarah, any preference? Yeah. Prefer not to do these in general? All right. No, I understand. Like I said, these aren't necessarily going to be the highlight of your day, is solving these kinds of things. But you know what? The time you spend on your education is going to be an investment that you're going to enjoy for a lifetime. It really is. So, let's see where we're going to use this stuff a little bit further. So, we're going to do a couple more examples. But let me just show you one all done up first. And just appreciate all the work that's going to go into what you're going to do, because we're going to do one just like this. So let me slide this over here and zoom in a little bit. So we're going to start out right here with this expression. So this one's kind of a real mess because you've got two square roots in the denominator and you got to get rid of both of them. The trick is, the trick that I mentioned we're going to keep track of in example D, and that is when you multiply conjugates together, you get some nice cancellation and you can get some radicals that'll disappear. So that's our trick here. If we look at this one carefully, you've got a square root of 11 plus a square root of 7 in the denominator. When I multiply by 1, that form of 1 is going to be the conjugate. It's square root of 11 minus square root of 7 in both the numerator and denominator. So a lot of work with FOIL in the denominator and in the numerator. I could have just written this as square root of 121 and square root of 49. I just jumped right to the 11 and the 7. Take care with the signs. One thing I did here is I showed the numerical value of this in each step. And notice numerically, every step of the way, you're getting the same thing. So all the way through. And this is where we're eventually going to get to, is this last step. So we clear up, like terms, we cancel, these cancel out together. In the numerator, they add because you got minus one of them here and minus one of them here, giving you a minus 2. You combine the 11 and the 7. If you get to here, that's 4 points out of 6. At least try and get to here. Now, it's tempting to cancel the 2 into the 4. That'd be great, but you can't. These terms in the numerator are kind of joined in a mathematical matrimony. They're married. You can't break that up. But what you can do is you can factor out the 2 from both the 18 and the second term. And once you have it factored, now you got 2 times something. Now you can cancel between a multiplication. And that last step gives you this as your final answer. So a lot going on. I would expect a problem like this on the exam. Try and get at least the 4 points here. But let's do a couple practice problems of this. We're going to start with this one down here. Square root of 13 minus 5 over square root of 13 plus 5. So I'm kind of out of sync with my numbering here, but let's do that. I don't want a whole question. So square root of 13 minus square root of 5 over square root of 13 plus square root of 5. So when we do this one, you realize you got a big mess in the denominator. So the trick is to multiply by 1. And if you get the right form of 1, that's probably 1 point worth of partial credit on your way to doing this one. Square root of 13 minus square root of 5, square root of 13 plus square root of 5. I've got to multiply by something over itself. What's that something going to be?
13 plus 5.
Square root of 13 plus square root of 5?
Square root of 13 plus 5. Square root, like square root of 5.
So the big thing that helped us out in example D was that these things had opposite signs. So those had to be opposite.
So could you FOIL?
Well, we will FOIL, but what I'm trying to get you to understand is what term to put here. I don't know. Okay, Colby?
When you just flip them, when you say, so you'd have 13, square root of 13 minus 5, and then on the numerator you say square root of 13 plus 5.
It has to be the same in both the numerator and denominator because you want to multiply effectively by 1, right? So for multiplying by 1, they have to be the same in the numerator and denominator. But you're right. Denominator, you need to flip that sign. So it needs to be opposite. So, you know, I'm not sure exactly what level of detail you're putting in your notes, but I would at least put in that part. That you've got to change that sign. That's what's going to make the denominator simplify the way we want to. All right, the rest, I mean, at least the next step is the FOIL part. So let's see what that's going to be. And I'll help you out with 13 times 13 is 169. 13 times 5 is 65. And then 5 times 5 is 25. Those terms are going to be the same in the numerator and denominator. But what detail have I not put in here for you? I haven't put in the signs. I'll give you a second to put in the signs. Try and put in those signs there. If you're watching this later, pause it for yourself, put in those signs, and then see what kind of simplification you can get from there.
Positive times negative is negative. So that would be a negative. Let's see. Positive times negative. Good. Nice. So, the signs. We have positive times positive. Positive times negative. And negative times positive. So it's first, outside, inside, left.
Okay, so we're going to FOIL these out. So just a kind of a quick reminder here, that's always first, outside, inside, last. Looking through these terms like that, first terms, positive times a positive, that's already positive. Outside, positive times a negative, it's going to give me a negative. And then a negative times a positive, another negative. Negative times a negative, positive. Cool. Someone walk me through the denominator. What signs am I going to get there in the denominator? Jocelyn, thanks for volunteering.
Positive.
Positive.
And then negative, and then positive.
Negative, positive.
And then another.
And then the last one is what?
A negative.
Negative. Good. Now the cool news in the denominator is because these are opposite in sign, those are going to cancel out. We get a lot more simplification Let's see what that is. Square root of 169 is 13. Square root of 25 is 5. Minus, how about that term in the middle? What are we going to get for that term in the middle?
2 square root 65.
Nice. 2 square roots of 65. In the denominator, things are even better because these terms were opposite in sign thanks to our clever choice up here. So those cancel out entirely. We get 13 minus 5, and I need to spill over onto the next sheet. So let's simplify things here. You know, let me just copy that. 13 minus 2 square roots of 65 plus 5 over 13 minus 5. Now let's simplify it from here. These can combine. 18 minus 2 square roots of 65 over 8. I know these are multiplied, but that whole numerator is kind of stuck together. So I can't cancel the 8 into the 2, as tempting as it may seem. But there is a common factor that I can take out, and that is a 2. Leave behind 9 minus the square root of 65 over 8. Now I can safely cancel the 2 and get 9 minus square root of 65 over 4. Beautiful. Beautiful. All right, that's a long one, and I promise you can expect one like that. So if there's some level of detail that I left out or something else you need help with, now's a good time to straighten things out. Something not sitting right with somebody? No? Gustavo? Good? Should we try another one?
Yeah.
Okay. All right. So let's see here. Let's do square root of 7 minus square root of 6 over square root of let's see how do I want to do square root of 13 plus the square root of 6. So this one's not going to simplify quite like the previous couple. That's okay. You are still going to start out kind of the same way. And, you know, even starting out the right way will earn you a point. And what I want to see from you first is, are you multiplying by the right thing to get started? So go ahead, give yourself a second, try and figure out what that is. And then we'll just double check that everyone's on the same page with what's going to go here and here. Volunteer? Send you?
13 squared minus 5, or minus 6 squared.
All right, square root of 13 minus square root of 6. How about the numerator?
Same.
Same. Nice. Square root of 13 minus square root of 6. Beautiful. All right, that's 1 point right there. At least starting out by multiplying by 1 in the form of the conjugate. Let's work with the denominator first, because that's going to be nice and easy. Should get some nice simplification. We already did 13 times 13. gave us 169. How about the outside terms? 6 times 13, that's 78. This is going to be a positive 78 or a negative 78? Negative. I should say square root of 78. So minus square root of 78. Inside terms gives us 78 again. What about the sign here?
Positive 78.
Positive 78. Awesome. Last terms. Let's see. Negative square root of 36. Great. In the numerator, Ryan C., maybe you can help me out. 7 times 13 is 91. But how about on the outside terms? What am I going to have there?
Negative square root of 42.
Negative square root of 42. Good. And the inside terms?
Negative square root of 78.
Nice. And the last term is going to be a positive square root of 36. Oh, excuse me, a negative. My bad. No, it is positive. Negative times a negative is going to be positive. Nice. Those terms in the denominator are going to cancel. Here we're going to end up with 13 minus 6. Not going to get anything pretty in the numerator. It's just going to be square root of 91 minus square root of 42 minus square root of 78 plus 6. And none of these are going to simplify. The only simplification you're going to get is in the denominator, which is a 7. Square root of 91 minus square root of 42 minus square root of 78 plus 6. And that is it. That's as far as we can go with that one. This one doesn't have the same kind of cancellation that we did with the other one. I was going to go with a slightly different problem. I was going to go with square root of 7 minus square root of 6 over square root of 7 plus square root of 6. The interesting thing that happens with this is that you end up with a 1 in the denominator. So it might be kind of fun to look at. Are we okay with these last two? All right. Yeah, please.
I'm getting, doing that, I'm getting kind of lost in all the math. Can I just do some box methods for the multiplication?
Yeah, you can do box methods if it helps you do the multiplication. I mean, eventually it's going to need to all go in the numerator or denominator. But yeah, you can do box method if you're multiplying binomials. Yeah, that still works here. So yeah, if that works for you, then good question. Thank you. Anything else? Yes.
Okay, I kind of got lost too, but just confirm, you take the opposite of the denominator.
Yeah, so the big thing that you should be getting here, when I form this term right here, it's what's called the conjugate. And all you're doing is you're changing the sign of the denominator term. So it's something over itself, but these are always going to be opposite. So to follow up on that one then, if I was going to do this one, what would I multiply by here?
Square root of 7 and negative square root of 6.
Good. And the same thing in the numerator. Now I'll kind of hurry this one up for you. You get square root of 49 minus square root of 42 plus square root of 42 minus square root of 36. And like I said earlier, you're going to end up with 7 minus 6, which is going to be your denominator, which is going to be 1. In the numerator, you know, if you want to use the box method up here, that's fine. You're going to get square root of 49 plus, or excuse me, minus square root of 42, minus square root of 42 again, and then plus square root of 36. So it's going to be 7. Yeah, I didn't leave myself enough room. Yeah, let's do it this way. Give myself a little bit more room here. So it's going to be 7 minus 2 square roots of 42 plus 6 all over 1, or 13 minus 2 square roots of 42. Yeah, and again, didn't leave myself enough room. My bad. So 2 square roots of 42. Yeah, so good job. You know, it's just a matter of changing up the sign on that term in order to get what you're going to multiply by. Does that help out, Irene?
Yeah, I'm just gonna, do it, like,
Yeah.
put that in my notes.
Sure. Oh, good idea. Good idea. Okay, cool. Let's take a break.